Hello everyone, how are you? I hope you are fine. Today we will solve new problem, which is problem 16, three-sum clauses. It's very similar to the previous problem, three-sum, but here we are not trying to find the target, we are trying to find the total of three numbers that is the closest possible to the target. So it could be, for example, closest to 1 could be 2 or 3 or 4, whatever we do, like summation of three numbers, and the best combination that gives us a total that is as close as possible to 1, that will be our answer. So in this example, minus 1, 2, 1 and minus 4, the best answer will be if we sum the minus 1 and 2 and 1, the total will be 2, and this answer is the closest possible to 1. So if we pick another different three numbers like minus 4 and let's say 2 and let's say 1, the answer will be minus 1, and minus 1 is two numbers far from 1, while 2 is one number far from 1, so 2 is the answer, is the correct answer. So I give you example here, this example, and the best way to start solving this problem is first by sorting it. And as you know, the sorting, it will be big N of log N operation, and because the sorting is N log N, but because we will do two loops, one to pick the first number A, and we will iterate through all numbers, so this is an operation. And for sorted list, the two-sum operation will be another n operation, so the total will be big O of n squared, and since big O of n squared is worse than n log n, so the overall time complexity will be big O of n squared, and this is the best solution that we can come with. So first we sort our array, and then we pick the first number as A, and then we start picking left and right to do the two-sum operation. Okay, two-sum operation, as you know, the left we will start from index A plus 1. So from the index of the A number plus 1. If A is here, we will start left here. If A is here, we will start left here, and so on. So first we will pick the first number as A, and then we do here two-sum operation. So to pick the left number and right number, and we add these three numbers, for example, minus 4 and minus 1 and 9 will give us 4. And we will start the closest, we initiate the value of the closest to be infinity, okay, and we have infinity, so we start from worst case possible, and we sum three numbers, and to find which one is more close to the target, which our target here is 1. So which of these two numbers is closest to the target? We find the best number, and here is 4, so we update the closest from infinity to become 4. And then we do three number operation again here, and we find a new target, new total. Maybe we find something, eventually we will find a new total equal 2, which will be 2 minus 1 is 1, the difference is 1, while 4 minus 1 is 3. So we know this new total is better than the current closest, and we will update the closest to become 2. Here, as you know, the two-sum operation, as you know it before, if the total is bigger than target, we move the high number to the left to pick a smaller number. If the total is less than the target, we move the small number to the right to have a bigger total, like pick this one, till we exit the loop or we find the best answer possible. Okay, so let's go to the Jupyter Lab and we solve this problem. Okay, so as mentioned before, we start with the closest equal infinity. So we pick a worst case scenario, and then we update it when we find a better solution. And of course, any solution will be better than infinity. And we sort our list. and we do iteration to pick the first number, which is a, and enumerate, and we loop through the nums. This is the outer loop to pick a. Now we do the two sum operation. We pick left and right index, and left index, it will start after a, so it will start like I plus 1, and right index is the end of the list, so it's the length of nums minus 1. And we do another loop for the two sum. While left is smaller than right, we are still good, so we calculate the total, which is a, plus the b, which is nums of left, and plus c, which is nums of right. This is the total that we will compare to a target, and the difference between total and target, we compare it between the current clauses and target. So if let's say absolute, we take the absolute value of total minus target less than the absolute value of closest minus target. So which difference is better? The new total difference to the target is lower than the current closest difference to the target. So if this is the case, we update the closest to pick the new difference, or sorry, not the new total. The closest will be the new total, because this is mean this new total is better than the current closest. So we say closest equal total. But if total bigger than target, we can say else if elif, or no, here is if, later we will do elif. If total is bigger than target, this is like two sum operation. We reduce the index of right index. Elif total smaller than target, we change the left index to the right side. Else here means total equal target. Here means total equal target. We, according to the problem description, we shouldn't have a case that three number totals should be equal to target, but I will put this scenario here anyway. If this is the case, so we found the best total possible, we just return it, even though we shouldn't have a total that's equal to target, but if we did, we will return it. And that's it. We come here and we return the closest, which is the best answer. So let me test it here. It's working fine. Let me take it, copy it, and go to the Leetcode to test it there. I pasted the code here. Let run submit, and to see if it's worked properly or not. Wrong answer. We have here some problem. 1, 3, 4, 7, 8, 9, and the target is 15. I found 14, expected 15. I found 14, but it's expected 15. We have 8 and 7, 3 numbers, 3, 4, 7, and 8. Should be 3, 4, and 8. So let me find out what I wrote wrong here to correct it, and I will be back to you. So I found the problem. I wrote here L while it should be minus equal 1, and this caused the problem. The best answer, now let's try again and see if it works properly. And yeah, it works properly. The time space complexity is good, memory complexity is good. Let's submit again and see. Yeah, now the memory is better. Thank you very much for watching, and I'll see you in the next video. Bye bye.